Welcome to our COA research project presentation, and this presentation will be based on the topic memory consistency models. Will be presented by Fatimata Isifu and myself, Josephine Koko Ofwe. So for the lineup of our presentation, we'll start with an introduction of our topic in a literature review, then go through some challenges that the literature review showed us, and find out about how to optimize performance, the limitations and directions that were made known to us through the articles, and how it improves such limitations, and finally conclude and add our own recommendations. So I begin with the introduction. So basically, a memory consistency model talks about how memory operations appear to execute to a programmer, and how those memory operations are ordered in the execution of the program to multiprocessors and other different processors. So how the memory operations perform or execute on either a multiprocessor or other different small more processors. So a few of our literature reviews include an article titled Recent Advances in Memory Consistency Models for Hardware Shared Memory. And another one also is the article on automatically comparing memory consistency model. Here are a few others as well.
Moving on to the challenges faced by software and hardware developers. The challenge faced by software and hardware developers is the high performance computing demands efficient and reliable memory consistency models in hardware shared memory systems. The memory consistency models define the order and visibility of memory operations between multiple threads. Also, the implementation of memory consistency models is complex and requires careful management to ensure correctness and performance. Another main challenge is the strong memory consistency models guarantee correctness but may cause significant performance overhead, and weak consistency models can improve performance but may introduce subtle bugs and errors. The last challenge is that ensuring data consistency across multiple processes and memory hierarchies in distributed systems requires complex synchronization and coordination mechanisms which can impact system performance. The limitations and direction. The traditional methods for defining memory consistency models have limitations in terms of time consumption and error proneness. To overcome these limitations, a possible approach is to use formal models to represent memory consistency models. Some techniques for optimizing performance and verifying correctness in memory consistency models. The main advanced techniques for optimizing performance and verifying correctness in memory consistency models is the in-depth examinations of memory technology and creating and applying new order consistency theories. How to improve efficiency and security. The continual enhancement of computer memory efficiency and security remains a persistent challenge for developers and researchers. Memory consistency models play a crucial role in determining the order of shared memory accesses in multi-threaded programs, thereby influencing performance and security. Recently, research has focused on innovative strategies for ensuring correctness and optimizing performance in memory consistency models. Additionally, novel methods have been explored to design secure non-volatile memory and reduce overhead in extended persistence domain memory systems.
So our conclusion is that consistency models are essential for ensuring correctness and efficiency of parallel program, but in order to make it more effective, We need to balance out performance and correctness of such memory consistency models. There are quite a number of recommendations we came up with. A few of them are that in the use of memory consistency model, one is to make sure to use one that is standardized and recognized nationwide. That helps a lot. And that in verifying the memory consistency model, it is preferably good to use the formal methods to do such verification. And lastly, when debugging the consistency model, it's advisable to use improved tools, such in the sense that it's better to use current softwares or tools to debug such program instead of using outdated versions of softwares to debug. Here are our references. That's all for our presentation. Thank you for your time.